morning, students. Hope you all are fine and you have revised which we have studied in previous class. Today we are going to study properties of rational numbers. Number 1, closure property. Rational numbers are closed under addition and subtraction. For example, when you will add two rational numbers or subtract two rational numbers, the resultant will be a rational number. See, for any two rational numbers, a by b and c by d, either you will add them or subtract. The result which you will get will be a rational number. For example, 4 by 9 plus 1 by 9, the result is 5 by 9, which is a rational number. Similarly, when you will subtract 1 by 9 from 4 by 9, again the result what you will get will be a rational number. So this is closure property. Next is commutative property. For any two rational numbers a by b and c by d, a by b plus c by d is equals to c by d plus a by b. Now with an example you see, when I had taken two rational numbers, that is 1 by 3 and 4 by 3. So either I will add 1 by 3 plus 4 by 3 or 4 by 3 plus 1 by 3. The result will be same. See how? So therefore the result is 5 by 3 is equals to 5 by 3. It means LHS is equals to RHS, which implies that rational numbers follow commutative property of addition. But it does not follow for subtraction. For example, 1 by 3 minus 4 by 3 will not be equal to 4 by 3 minus 1 by 3. That is 1 minus 4 by 3 is not equal to 4 minus 1 by 3. After solving, you will get the result as minus 1 not equal to 1. So that means this is not for subtraction. Next, we are going to study associative property of associative property. Addition is associative for rational numbers. For any three rational numbers, a by b, c by d and e by f, we have a by b plus c by d in bracket plus e by f. That is equals to a by b plus in bracket c by d plus e by f. So this mathematical statement we are going to prove by taking an example. So three rational number I have taken, that is minus 1 by 3, 2 by 7 and minus 5 by 3. And these values I have put in this mathematical statement. And both I have solved simultaneously, LHS and RHS. So first in this case we have to solve bracket first. That is minus 1 by 3 plus 2 by 7 by taking LCM and adding it. Similarly in RHS also. So after solving, you can see the result as minus 36 by 21 on both the sides. Further reducing it, we will get minus 12 by 7 is equals to minus 12 by 7. It means that either you add any two numbers first and then the third number, the result will, anyway you will add, the resultant will be equal. Next is subtraction is not associative. It means that like addition, you are not supposed to do subtraction for rational numbers. Here I have picked another three rational number, that is 2 by 3, 1 by 3 and 1 by 2. And I have solved both LHS and RHS. After solving, you can see that the result is not equal. That is, in LHS I have got minus 1 by 6 and in RHS 5 by 6. That means both the result are not equal. means LHS is not equals to RHS. So that means again associative property is follows addition but not subtraction. Instance of additive identity. 0 is the identity element of rational numbers. That means for any rational number, when you will add 0, the result will be that number itself. A by B plus 0 is equals to A by B. Another example, 5 by 8 plus 0, that is equals to 5 by 8. One more example, minus 2 by 3 plus 0 is equals to minus 2 by 3, that is the number itself. So therefore 0 is the identity element of rational numbers. Identity, or you can say additive identity of rational numbers. Next is existence of additive inverse. For every rational number A by B, there exists a rational number minus A by B, such that A by B plus minus A by B is equals to 0. It means when you will add a rational number to another rational number, then the result will be 0, then both the numbers will be called additive inverse of each other. In this case, A by B is additive inverse of minus A by B, and minus A by B is the additive inverse of A by B. For example, 5 by 3 plus minus 5 by 3. When you will add them, the result will be 0. So therefore minus 5 by 3 is additive inverse of 5 by 3. Or you can say 5 by 3 is the additive inverse of minus 5 by 3. One more example, minus 2 by 5 plus 2 by 5 will give you 0. Now we have discussed about the property of rational number for addition and subtraction. Now we are going to discuss property of multiplication of rational numbers. Number 1, closure property. So for any two rational numbers, when you will multiply them, the result will be a rational number. For example, 1 by 2 into 1 by 3 is equals to 1 by 6. So 1 by 6 is also a rational number. Next is commutative property. For any two rational numbers A by B and C by D, A by B into C by D is equals to C by D into A by B. Now this is being proved by taking an example. 1 by 3 into 2 by 5 is equals to 2 by 5 into 1 by 3. So the result, you can see LHS is equals to RHS. Now next property is associative property. Associative property. For any three rational number A by B, C by D and E by F, A by B into C by D in bracket into E by F is equals to A by B into in bracket C by D into E by F. Now this property we are going to prove with an example. 1 by 2 into 1 by 3 into 8 by 5 is equals to 1 by 2 into in bracket 1 by 3 into 8 by 5. So here we have to solve both LHS and RHS simultaneously, or you can solve this separately also to check whether LHS is equals to RHS or not. So I have solved it simultaneously. You can see first you have to solve here bracket and then you have to multiply with 8 by 5. Here also you have to solve bracket first. So anyway you have done this, then the result is 4 by 15 in both the cases. So here we can see LHS is equals to RHS. So next property is existence of multiplicative identity. For any rational number a by b, when you will multiply 1, the result will be the rational number itself. A by b into 1 is equals to a by b. So that means 1 is the multiplicative identity of rational numbers. For example, I have taken 2 by 7 and minus 3 by 14 as a rational number, and I have multiplied 1. So the result what I have got is 2 by 7, and here minus 3 by 14, the number itself. So therefore 1 is known as multiplicative identity. Next property is existence of multiplicative inverse. For every non-zero rational number a by b, there is multiplicative inverse b by a such that a by b into b by a is equals to 1. Let me explain first what is non-zero rational number. You should not, 0 is also a rational number, but we should not take 0 in this case, because 0 is a rational number, because we can write 0 as 0 by 1. But when you will take the inverse, it will become 1 by 0, which is not a rational number. So 0 should not be considered in this case. So except 0, it is applicable to all the rational numbers. So for example, 7 by 5. So what is the reciprocal of 7 by 5 if I ask? So the answer should be 5 by 7. Why? Because when you will multiply a number by its reciprocal or multiplicative inverse. Let me tell you, reciprocal of a number and multiplicative inverse, that is the same thing. So don't get confused. When you will multiply 7 by 5 into multiplicative inverse of 7 by 5, that is 5 by 7, that product will be 1 always. Let us solve this by taking an example with negative sign. So minus 2 by 3. So when you will multiply it with, suppose 3 by 2, so the result will be minus 1. So multiplicative inverse of minus 2 by 3 is not 3 by 2. It should be minus 3 by 2. So this case should be remembered. So now you can see, when you will find product of these numbers, the result is 1. So that means this number is multiplicative inverse of this number. Distributive property of multiplication over addition. For this, I have taken 3 rational numbers, that is a by b, c by d and e by f. If there are 3 rational numbers, then the property can be written as a by b into in bracket c by d plus e by f bracket closed is equals to a by b into c by d plus a by b into e by f. For example, 2 by 3 into in bracket 3 by 4 plus 5 by 6 is equals to 2 by 3 into 3 by 4 plus 2 by 3 into 5 by 6. For this I have taken 3 rational number and I have substituted in this mathematical statement. Now both LHS and RHS I have solved simultaneously. First, as per rule, you have to solve bracket first by taking LCM. Solving, I have got 19 by 12. Then again here 2 by 3 into 19 by 12 is equals to, by taking LCM, 9 plus 10 by 18. So here you can see both LHS and RHS are equal. So one more example I have taken by taking negative rational number. So minus 4 by 5, another one is 2 by 3 and another one is minus 1 by 4. By taking these 3 rational numbers, I am proving the same property. You see, minus 4 by 5 into in bracket 2 by 3 plus minus 1 by 4 is equals to minus 4 by 5 into 2 by 3 plus minus 4 by 5 into minus 1 by 4. Both LHS and RHS you have to solve. First you have to solve bracket, and then further you have to do multiplication. And then by taking here LCM, you can see I have got the result minus 1 by 3 and minus 1 by 3, both in LHS and RHS. So from this, today we have covered entire properties of rational number, and I would like to say that you should take your own examples and then solve it. Try to prove these properties by yourself so that you will get more practice and you will understand more clearly. And now I would like to say that more practice and assignment will be sent through ERP. Thank you, children.